All right, guys, this is a video for least common multiple using prime factorization. So we're just going to jump right in. We have two numbers here, 4 and 6. We're looking for their least common multiple. Multiple is kind of what you think about when you're skip counting: 2, 4, 6, 8, 10, 5, 10, 15, 20, that kind of thing. That's a multiple. So we're looking, what multiple do they share that's the smallest? So what would you skip count to, and which would be the smallest that you would get to for both of them? So what we're going to do is we're going to start off by doing a factor tree. Okay, so what two factors make 4? Well, I know that 2 times 2 makes 4. Both of those numbers are prime, so we're good. They're all done. So we'll write 4 is the same as 2 times 2. Now 6, we can do 2 times 3. These are also prime numbers, so we can write our list out. 6 is the same as 2 times 3. So what I like to do is I like to start by bringing this list down. So I'm going to do the first pair. So 2 times 2. So I have gone ahead and moved those down. Now I'm going to look over at this part here. And I see a 2 already represented, so I'm going to cross this one out. I don't need it. And I'm going to look back at my list. There's already 2. I don't care about that one. That one's good. But then I look back here and I can see that there's no 3 already represented. So I'm going to bring this down. Then we can cross it off. So now all numbers have been combined and not repeated. So we can see here 2 times 2, that's 4, and 4 times 3 is 12. So the least common multiple between 4 and 6 is 12. Let's try a problem that has a little bit larger numbers. So we have 16 and 24 here. So what I'm going to do is start off by using little factor trees here. I know that 16 is the same as 4 times 4, but both of those numbers are not prime. So I'm going to go ahead and decompose those a little bit more to make them prime factors. Okay, so now that's done. My 2's are all prime numbers, so that's good. So 16 is the same as 2 times 2 times 2 times 2. Now let's move over to the 24. 24, let's do 6 times 4. Both of those numbers are not prime. So we're going to go ahead and decompose them into prime factors. Woohoo! Those are all good. So let's do 24 is the same as 2 times 3 times 2 times 2. Okay, so this spot is the same step that you would get to if you're looking for greatest common factor. This next step is what you're going to do a little bit differently. In least common multiple, you're looking to combine your list of prime factors. Okay, in greatest common factor, you're trying to see which ones they share. So in least common multiple, remember, we're combining our list here. So I'm going to go ahead and drag this list down first. So 2 times 2 times 2 times 2. I like to mark it out so that I know I've already represented those. Then I'm going to look through my list. Here's a 2. Here's a 2. Don't need it. Here's a 2. Here's a 2. Don't need it. Here's a 2. Here's a 2. Don't need it. And then we have a 2, but there's none left, so we're just going to keep that one. And what do we have left in our next list? That times 3. So now we can just go ahead and multiply. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 3, oops, I didn't mean to put that 3 there. 16 times 3, if you cannot do that in your head, do not ever feel ashamed to write it down. 6 times 3 is 18. 3 times 1, 10 is 40. Because we have that there, right? I use partial products, so it would look like this. Well, let me just do it the normal way. Okay, 6 times 3 is 18, carry 1. 3 times 1 is 3, plus 1 is 4. So then we have 48. So our least common multiple between these numbers is 48. Okay. Also, you see how I had to write my 16 times 3? I eventually would have been able to get it in my head, but it would have taken me a lot longer and I might not have been as accurate. So if you're finding that you're like, oh, I can do these, but this last step I can't do in my head, always write it down. Okay, you'll be far more accurate if you do. Okay, so our least common multiple, 48. So if I skip counted by 16, I would eventually get to 48. If I skip counted by 24s, I would eventually get to 48, and that's the smallest number that they both share. Alrighty, my friends. Hope you have fun with prime factorization. I love this. I think it's so cool to stretch your brain with different ways of dealing with numbers. Let me know if you have any questions about these.